Hello everyone. Welcome to another lecture. In this video, we will talk about mesh analysis, another type of circuit analysis method. A mesh is a loop that does not contain any other loops within it. Mesh analysis makes use of mesh currents as circuit variables instead of element currents as seen when doing KVL analysis. Each mesh loop has a current variable assigned to it. To perform mesh analysis, follow these steps. Step 1. Assign mesh currents to each mesh. Step 2. Apply KVL to each mesh. Use Ohm's law to express the resistor voltages as mesh currents. Also, when an element intersects between two meshes, the mesh currents are subtracted. This is because the currents enters the element from both directions. Subtracting it finds the element's current. How the current is subtracted depends on which mesh you're working with. Finally, step 3. Solve the equations to get the mesh currents. To illustrate the steps, we will use this circuit. First, the mesh loop's currents were assigned. Then the KVL for each mesh were found. There are two meshes. Resistor 3 is between two meshes, so it has a mesh current entering from both directions. For the first KVL in loop 1, the mesh current of resistor 3 I1 is subtracted by the intersecting mesh current of resistor 3 I2 in loop 2. The current of I1 and I2 are switched for resistor 3 when finding the KVL of mesh 2. So the currents are subtracted and multiplied by the resistor value to obtain the voltage. Let's use values to make things clearer. In this example, we will calculate the mesh current I1 and I2. Also find the current of resistor 1. Since the mesh currents are already assigned, let us find the KVL equations. Now that we have the KVL equations and have simplified it, let's solve the equations. With the two equations we found, we can find the mesh currents and resistor 1 current. I1 equals 2 amps and I2 equals 0 amps. The current of resistor 1 equals 2 amps. Mesh analysis becomes a little different when current sources are involved. Case 1. When the current source is in one mesh only. In this circuit, the current source is in mesh 2 only. You will find the KVL as usual for mesh 1, but for mesh 2, the mesh current is equal to the flow of the current source. In this diagram, since the current source opposes the direction of the mesh current is negative. In case 2, the current source is between two meshes. In this circuit, the current source is between mesh 1 and mesh 2. Finding the voltages of each resistor in mesh analysis will be as usual, but the current source between the meshes is temporarily taken out. That current source and all elements connected in series with it are removed. The two meshes becomes one mesh called a super mesh. The KVL of the super mesh plus any other mesh will be found and used as equations. Then the circuit will go back to its original form. This is where we will find the KCL of the node that intersects between the two meshes to use as an equation. The variables of the KCL and KVL should be the mesh currents like in this circuit. But let me show you a more complex example. In this example, use mesh analysis to find the mesh currents. To start, label the mesh current. We should now continue to analyze the circuit. A current source exists between mesh 1 and 3. The current source is removed along with the rest of the elements connected in series to it. The three meshes in the circuit turn into a super mesh and a single mesh. Find the KVL. Now we have found the KVL equations. But by looking, it is not enough to find the values. We will now go back to the original circuit and find the KCL of the node that intersects between the two meshes. Mesh 1 and mesh 3. Let's call it node A. I1 is leaving node A. The 3 amp source and I2 are entering node A. The KCL at node A produces another equation. With the three equations, we can find the mesh currents. I1 equals 3.474 amps. I2 equals 1.105 amps. I3 equals 0.474 amps. That will be all. Thanks you all for listening to another lecture.